In this example, we'll be approximating the square root of 110 to the nearest tenth place decimal. To do this, we want to look at perfect squares nearby to 110. 10 squared is equal to 100, while 11 squared is equal to 121. We can see that 110 fits between 100 and 121. So then we can write the following inequality. 100 is less than 110, which is less than 121. Now we can take the square root of all of these values. The square root of 100 is equal to 10, as 10 squared is equal to 100. The square root of 121 is equal to 11, as 11 squared is equal to 121. Now we can see the square root of 110 is between 10 and 11. So we want to try a tenths place decimal between 10 and 11 that when we square that value will give us about 110. Because 110 is 10 away from 100 and 11 away from 121, we can try something that's between 10 and 11, like 10.5 squared, and see how close we get to 110. Let's multiply 10.5 times 10.5. 5 times 5 is 25, carry the 2. 0 times 5 is 0, plus 2 is 2, and then 1 times 5 is 5. Add zeros for our next row since we're multiplying by 0, and 2 placeholders for our final row. 1 times 5 is 5, 1 times 0 is 0, and then 1 times 1 is 1. When we add these together, we end up getting 110.25, which is very close to 110. So we can approximate this as 110. We can then write the following approximation. 10.5 squared is approximately 110. Taking the square root of both sides will cancel the squared and the square root for the 10.5, leaving us the 10.5 is approximately the square root of 110, and this will be our approximated solution.